Okay, part 2. Use the properties of logarithms to write each as a single logarithm. Now I know I got kind of crazy in class, but these sort of things are what you guys remember. These are the marriage rules. The two shall become one. Now when you got 3 of them, you need to kind of chunk out 2. Don't worry about all 3 of them at the same time. Let's just figure this out. Remember what I said, look for law 3 first, which is right here and right here. So we're going to just apply this and we're going to rewrite it like this simply because we can. But now the 2 shall become 1. We have 2 logs. We want 1. Subtraction means division, so r cubed over s squared. Now we still have the plus log of t. So we have 2 logs, and the 2 shall become 1. Addition means multiplication, so that's actually t over 1. So if we multiply that together, we get r cubed t all over s. That will be our final answer. Same thing here, but this time I'm just going to go law 3. Natural log of 3 squared is 9. Now I know that 4 goes right there. I'm just going to get rid of it. 2 to the 4th is 16. Minus the lateral log of 36. Now that we've cleaned that up, watch how this goes. We're going to start with these 2. The 2 shall become 1. These are going to be multiplied. So 9 times 16 is 144. Minus the natural log of 36. The 2 shall become 1. Subtraction means division, so I'll show my work. And then we reduce that, and that just happens to be a nice, clean natural log of 4. Keep going. Use the properties of logarithms to expand. And when I taught this, I called it the mall. We're going to take that 1 log and we're going to split the log into multiple logs. We're going to start right here. We know that division equals subtraction. So we're going to start with this. The top part goes like this. Subtraction goes like this. Now you have followed the rules and you split it, but notice we can take another swing at this log because these 2 things are connected by multiplication. We're not worried about the 6's, so don't get overly concerned with that. And I'm not worried about this. It's just here. So multiplication means addition. So we get x cubed plus log b y to the 5th minus log 6c. Now here's the thing. Law 3 is always lurking. You have 100% followed the instructions, but they're not done with you probably because they want you to practice or look for law 3. So that should come in the front. Even though this is 100% correct, they're going to want you to know that it equals this. So I can bring that in the front. Those are 6's. I'm making them look like b's. Minus log 6z. That's probably what they're looking for if this is a multiple choice situation. And if it's fill in the blank, they probably want you to go here. I'd have a hard time marking it wrong if you left it here, but this is the goal. Let's keep going. Division means subtraction. 7y cubed minus log x squared. Well, these are connected by multiplication, so I'm going to swing one more time at these. So it's plus log y cubed minus log x squared. Look for law 3, bring that in the front. Look for law 3, bring that in the front. This thing's just stuck. Minus 2 log of x. I'm very certain this is what they want right there. Okay, number 14, here we go. Can you divide both sides by 5? No. That's not a 5. That's 5 to some power. You don't know what that really is, so be careful. But when I say common bases, happy places, like can I write 200 as a power of 5? So that's 5. That's 25. That's 125. 5 to the 4th is 625. So there's no way I can rewrite 200 as 5 to some nice, neat power. This is where you got to slap the logs on and then follow through. Here's law 3. This is why you learn law 3. X comes in front. I'm going to look up log of 5, and that's 0.699. Probably should just call that 0.7. And then I look up log of 200, 2.3. Then I got to take 2.3, divide that by 0.699, being pretty accurate here. We'll just go, X is 3.29. That's how you get those done. Same thing here. There's no way I know that 7 cubed is 343, so there's really no, 7 to the 4th is definitely not, it's not that easy. So I'm going to go like this, 7 to the x equals 486. Now why did I leave a space here? Because I'm going to slap a log on here, slap a log on here, common basis. So there's a 10 here and a 10 here. So you're using logs the way they're designed to be used. So we take the x, bring it in the front. We look up log of 7. We get 0.845. And then I look up log of 486. 2.69. And then I divide by 0.845. Divide by 0.845. 3.18. 3.18 for that one. Now, solve for x. You could use this technique of slapping logs on both sides, but you don't have to, so I'm not showing that method. I notice there's a 2 here and an 8 here. I'm going to turn that 8 into 2 cubed. Common bases, happy places. Now I see that we have power to a power, so we're going to multiply. And this is just going to stay, because now we have common bases, they disappear. So 5x plus 1 equals 3x minus 3. Subtract 3x, subtract 3x, subtract 1, subtract 1. 2x equals negative 4. Divide by 2, I get negative 2. Those are kind of fun. Now notice we got a 9 and a 27. A lot of students will take this and go 9 times 3. You're heading in the right direction, but that's going to take you down a terrible rabbit trail. I'm going to write 9 as 3 squared, and I'm going to write 27 as 3 cubed. See, that's a no-brainer, common bases. Common bases, happy places. So I got 2x plus 3. That's a 3. So, power to a power, you multiply. So I get 4x plus 6. Power to a power, I multiply, so I get 3x plus 6. These cancel. This has to equal this. So 4x plus 6 has to equal 3x plus 6. Subtract 3x, subtract 3x, subtract 6, subtract 6. Whoop. So I end up getting x is 0. Everything just disappears. So x is 0. Let's go to this one. A little different twist here. Start here, go there, go there. How did I know to do that? That's just what a logarithm is, and it allows me to do it. So 5 squared equals 3x minus 2. I'm going to add 2. Add 2. I know that's 25. 25 and 2 is 27 equals 3x. Divide by 3, divide by 3. I get x is 9. You just got to be looking for that. This one, there's an e there. There's an e there. So, truthfully, this stuff has to equal that stuff. So I get x squared minus 32 equals 4x. It's kind of like how in this situation the 3's disappeared and this had to equal this. This stuff just has to equal that stuff. Subtract 4x, subtract 4x. Now there's a little twist coming, so pay attention. Minus 4x minus 32 equals 0. Got to factor that bad boy. X minus 8, x plus 4, so that's 8 or negative 4. Now before you just go to the next problem, you must check these answers. Remember, if you have a log or a lateral nog, you can never have a negative in that space. So you got to look out for this. Well, if I plug the 8 in there, I get 64 minus 32. That's good. And then I get 8 times 4 is 32. That's a winner, winner, chicken dinner. But this is dangerous. If I put that negative 4 in there, I get a negative 16. That throws it out. This is your only answer. All right, moving along. Last 4 problems. So this situation, we got a log on this side, a log on that side, but we got the sneaky little law of 3. Remember, look out for law of 3. So I'm going to rewrite this as x squared. Now, if I set that like this, 2x plus 3, see if I can sneak it in there. You can see that this has to equal that. So 2x plus 3 equals x squared. We have a trinomial. Hopefully you guys are getting really rock solid on these types. Now we can factor that little bad boy. X minus 3, x plus 1. So x is 3 or negative 1. Now, don't throw out a negative just because it's negative. You got to plug it back in. Will that cause this to be negative? Yes. And we can't have a negative there. If we plug this in, that's 6 plus 3 is 9. And then we get this 3 here, that's fine. So there's our answer for that one. All right, letter F. So can I divide both sides by 10? No, bad move, because we don't know what x is, so we don't even know if that's a 10. How do we solve for this? Well, I'm going to rewrite it a little different. I can see what's coming. There's no way I'm finding common bases, so I'm going to slap a log on there. Slap a log on there. That allows me to bring that in the front. So I get 2x minus 1 times log of 10. Now let's visit this a second. Remember, that's kind of a problem all by itself. What does this equal? Well, there's a 10 here. 10 to the what power is 10? That's 1. So this really turns into 1. You can type it in your calculator to kind of figure that. So if I just type in log of 10, log of 10 gives me 1, but I explained why right here. So really, if I look up log of 52 now, I get 1.72. So 1.72 equals 2x minus 1, add 1, add 1. 2.72 equals 2x, divide by 2, divide by 2. So 2.72 divided by 2. 1.36 equals x. Now for these, I'm going to do a little something for you, and then I'll be right back. All right, let's read the instructions. Determine whether or not each sequence is geometric. Remember, if it's geometric, there's going to be a multiplier connector R. And we can always look at the first to the second. We go, multiply that by 2, but that has to be consistent. That would need to be an 8 in order for this to be considered a geometric sequence. So we know this is not 1, and so we can just stop. But if we keep reading the instructions, it says, if it is, write the explicit formula. Now, I took some time here. Remember, this is our recursive language. This is our explicit language. Now, this means find R, because that's really the meat and potatoes. This is pretty easy. That's our first term. So that's a sub n equals our first term times R, find it. Well, 2 times 2 is 4, times 2 is 8, times 2 is 16. We can see that R is 2. So we're just going to put that in there, 2, and then n minus 1. Which means if they asked us to find like the 27th term, we could put 27 in there and just multiply it all out. But this is all they wanted for this question, so we are done. Congratulations.